Hey, this is Dr. B here, and it's time for worksheet 7.8, the types of bonds worksheets. We'll be looking at ionic, covalent, and metallic bonds. Chemical bonds, like people, exhibit varying degrees of selfishness. Some bonds are shared unequally. One element may be giving an electron, the other one may be taking it. If that's the case, we can call that an ionic bond. Others can share their electrons evenly, or more or less evenly. We call those covalent bonds. If they're really evenly shared, we'll call them nonpolar covalent. That requires those nonmetals, and those are the ones that do it, to be either identical or a carbon-to-hydrogen bond, which is close enough. If they're unevenly shared, we call those polarized or polar covalent bonds. And that happens when you have non-identical nonmetals. I hope that makes sense. Perhaps the most shared electrons in bonding are the metallic bonds, which involve a mobile sea of electrons. Examples summarized can be shown here. If it's between two metals, easy, metallic bond. Metal and a nonmetal, also easy, that's ionic. If it's a nonmetal and they're identical, that means they're nonpolar, evenly shared, covalent. And if they're two different nonmetals, that's polar covalent. A couple things about hydrogen. If it's bonded to carbon, those polarities are close enough that we call that nonpolar covalent, and also realize that although hydrogen is to the left of the staircase, it clearly is a nonmetal. By the way, there is a polyatomic substance which is not a metal, but it can still form an ionic bond, and the most common one is ammonium. So ammonium iodide. It's not metal to nonmetal, but it's still an ionic compound. Okay, let's solve some problems. NaCl. By the way, if you need it, have a periodic table out and use it to solve these. Sodium, metal, chloride, nonmetal, ionic. Carbon, nonmetal, oxygen, nonmetal, non-identical, polar covalent. Both identical nonmetals, nonpolar covalent. Metal, nonmetal, ionic. Metal, nonmetal, ionic. Carbon to hydrogen, that's the exception, nonpolar covalent. Just barely a nonmetal. The metalloids that are to the right of the staircase, we count them as nonmetal just to give us a clean answer. This would be non-identical nonmetals, therefore polar covalent. Metal, nonmetal, ionic. Metals, so metallic. Metal, nonmetal, ionic. Metal, nonmetal, ionic. Identical nonmetals. Remember what we said about hydrogen? Nonpolar covalent. Draw sodium and chlorine as they become ionic and become attracted to each other is what this question's saying. So let's draw that one valence electron in sodium, adding to the 7 valence electrons that chlorine has and to which it so desperately wants to complete its octet. And then circle it, showing that they each have 8 valence electrons by sharing 2. And the chloride has the 8 and the sodium has none at all. They form a bond between themselves, and there you go. Here is CF4 shown in all its glory and all its stability. They're asking you to show it and show how every single element has its 8 valence electrons. Look at those circles and convince yourself they all have 8. Carbon started with 4, fluorines started with 7, and they're sharing 2 per atom. 8, 8, 8, 8, and the 2 electrons can be represented, if you want, with lines, where a line is that covalent bond consisting of the sharing of 2 electrons. Here's a hypothetical substance, which is pretty crazy. I mean, the honk rules look reasonable, but it's crazy just the same. We're trying to show every single type of bond. Let's name them all. I'm going to try to go from left to right and hope that they do as well. Hydrogen to carbon, that looks like nonpolar covalent. Oh, let's do them all. Let's do it and then reveal it. Nonpolar covalent, carbon to hydrogen. I'm going to go around the horn like this. Bromine to nitrogen, polar covalent, non-identical nonmetals. Nitrogen to silicon, still polar covalent. How about carbon to oxygen? Still polar covalent, both sides obviously. Carbon to oxygen, polar covalent. Oxygen to sodium. Sodium's a metal. There's your ionic bond right there. This one is also technically ionic since silicon is a nonmetal, lithium's a metal. This is polar covalent. Boy, we got a lot of polar covalent. Polar covalent, polar covalent. Tons of polar covalent there. And only one ionic and one nonpolar covalent. Okay, this was the Types of Bonds worksheet.